very much for coming today to our live stream from MetaPilot Academy. I am here today with Dr. Frederick Gregory, and I'm actually really excited to talk about the new program that we launched, which is a Master in Neurotechnology. I've been thinking about it for a long time, obviously, given my background in neurobiology and then later on in neurotechnology. Dr. Gregory is obviously an expert in the field as well, and has been one of the first people to even start reviewing the first attempts of neuroscience going out of the lab, out of the academic lab. So things are changing really fast, at a very fast pace. I was around, when sort of pre Neuralink, pre kernel, the first attempts to scale neurotechnology in general. I have also seen different attempts of going at it, from neuromorphic to brain machine interfaces to people looking at product market fit to applications in defense and aerospace and mobility. Tesla using insights from the visual cortex, all of these things that are super exciting. And I've also seen the potential pitfalls. One is academia losing its top talent, just because of the issues with academia, one of them being, salaries. The other one is I've also seen, unfortunately, a lot of companies that claim to be neuroscientific but ended up being more of either a wearable or some gadget, right? That is not necessarily a bad thing in itself, but it can misconstrue what neurotechnology is about and what it is and what it entails. So hopefully we're going to speak about that today also with Dr. Gregory. I'll start by introducing myself, and I'll let him introduce himself. So I'm Dr. Dana Deka. I manage MetaPilot Academy and the company Neurobotics, which is a Boeing-funded neuromorphic company. Out of that, MetaPilot Academy spun out with this aerospace and defense programs initially that were actually centered around the product market fit we've seen with neuroscience. So in a way, this Master's in Neurotechnology is just full circle, going back to the core of every application that we've seen. My work has been on cellular neurobiology in my PhD, so 2-photon imaging, electrophysiology, building up a lot of these 2-photon microscopes, setting up electrophysiology rigs, and doing a lot of acute surgeries in mice. First superficial ones, looking at the visual or auditory cortex, and then I went to look into the medial entorhinal cortex, working with NTA in Norway. And so there I ended up setting, I think, what was the 11th setup that I worked on and helped put together. And it was the first time we actually got to see the neurons in action that are so deep in the brain and that form what we call a spatial map. So my professors actually got the Nobel Prize for that discovery. And then I got really into spatial computing. I thought more people need to know about this. It's crazy that only 10 people even know that spatial computing is done in the brain and how it is done and what we can extract from there. And I started Neurobotics, which brings me to this point now. Very happy to be here. Happy to have you guys tuning in. And I'll leave it to Fred to introduce himself. Probably because I'm going to exaggerate or say the wrong thing. But yeah, let's just get started with that.
Yep, and I'm Fred Gregory. So also a cellular neuroscientist and electrophysiologist, trained in patch clamp techniques, initially focused on vestibular neurons in the inner ear, and kind of looking at the fundamental mechanisms of synaptic release. Using capacitance measurements, so really looking at vesicular fusion events at individual synapses, then moving into ion channel physiology, and specifically looking at voltage-gated calcium channels at those release sites, and defining fundamental mechanisms that are involved in auditory disorders, and connecting those synaptic events, calcium channelopathies, to auditory dysfunction, and then sort of shifting into a new life, moving into the military research environment at Army Research Lab for the past 13 years, 12 years, almost 13 years, where it took me into this very different view of neuroscience, and going into the research development and engineering command what it used to be called in the Army, where it was non-medical. So moving from a foundation in biomedical implications in neuroscience to military non-medical, it really forced my hand quite a bit, and I think made me a better scientist and opened my eyes to broader applications of neuroscience. So thinking along the lines from human performance to human computer interactions, now thinking about human autonomy teaming, and spanning the spectrum from really from atomic, cellular, molecular mechanisms all the way to social dynamics, and then out into socio-technical domains with the human machine interface. So really thinking broadly around neuroscience and multidisciplinary opportunities that allowed me to be at the forefront with DARPA during the initial days of the Brain Initiative, and seeing the beginnings of the past decade plus, from foundational neuroscience through to this major initiative in the U.S. that turned into a global initiative, being centered abroad from London, seeing major aspects of the Brain Initiative play out. I think it gives us an opportunity here within the course to speak to that historical context. So really speaking to that past decade plus of where neuroscience as a field and society has enabled and de-risked the opportunities that we see today in the commercial space, with companies like Neuralink and Neurable and other players who are now in the limelight. And so putting everything in context and seeing how science, these basic thoughts, these basic mechanisms that we talk about in the academic setting, how they can be applied in new ways, and intersecting with industry to build the future. And so we've been laying the foundation for that future. And particularly now in Metapilot Academy, the intersection of those outcomes now with respect to a new multidisciplinary opportunity, the one that comes to light with in the aerospace and future mobility sectors. So looking forward to what's to come, and excited about our new launch.
Fantastic. Well, first of all, it's great to see two electrophysiologists doing anything other than experiments, and having a look at industry and where neurotechnology could be going. And it's actually really exciting to have someone that has overseen the early DARPA efforts going into funding neurotechnology. I guess now Europe is also trying to make some steps in that direction. One thing is obvious with neurotechnology, the possibilities are endless, but they are not in the near future. They require FDA approval, and we've seen some attempts in Europe. Paradromic, Synchron, and Brain did pretty well. Quite a few of them are going into clinical trials. And we're seeing good reactions to the implants as well, the materials, the way things are done. We still need to figure out the product market fit. And this is where, people that had this experience, like you and I, Fred, that, went from the experimental room into a completely novel sector, which is defense or, aerospace. We got to get an idea of how incredibly transformative real neurotechnology can be, right? In fact, it is one of the few things that I can think of that if you look at the possibilities, that they're actually hard to conceive, right? There's this saying that if our brain was so simple that we could understand it, we would be so simple that we couldn't, right? That's is the final frontier. So anyway, I'm just going to get straight into it and kind of explain what the program is about, and then we can both go into discussion, where this can go, and who we would like to have involved at this stage, and kind of building on what we've done so far with the academy. I think by now we have close to 100 applicants for our first program. We chose, I think, 10, 15 of those. And we're obviously very selective about the kind of people that enter the network, but in total, it's a network of 50,000 industry leaders. So we're very particular about who is coming in, but it's also like a great space to try things out. Fred, could you confirm that you can see my slides?
Yes, I can see them.
Super. So at some point I'm going to stop in between, and we can go into discussion, and then of course if people want to go into Q&A, we can do that. But just brief recap on the academy. So it's a combination of things that kind of look like a business school in the beginning. We gave it that structure. The reason is because I wanted people to get an overview of the industry. I have not seen a real program where people get that for many reasons. I think I don't want to discuss that. I just want, I wanted people to have an overview that I did not have at that age, which is to understand what is out there, what can be done. And within that, it gives you the possibility to specialize and to find out where your talent is, your ikigai, if you will. And the main thing is the teaching and the workshops are all done by people that are active in the industry and are representing either large OEMs or very fast scaling startups. So that's kind of the approach, the top 1%. Just because I've been in MBAs, I've been teaching in them, and I see no point in students learning from a consultant or someone who is not really connected to the industry, right? Every moment is important, and we need to make the best of it. So we live in an age of fast transfer between the two generations, and the ones that are going to lead the AI revolution or the robotics one or the manufacturing one or the aerospace or the neurotech one, we need very fast transfer of information. Why do we need this transfer to be fast? Because there's been a lot of funding going into defense and aerospace, close to 5 trillion by now. I think the EU has also just launched a 5 billion, maybe yearly 5 billion fund into technology. So obviously each continent, China, the US, Europe, are trying to compete now. NATO, Germany especially is going towards 1 trillion investment as well in AGI defense. And what that does is it creates new career paths. It also opens doors that we didn't think about opening before. Obviously, reusable rockets are a great example. Flying cars are another. One neurotech leads to full autonomy or perfect communication between, let's say, the motor cortex and anything that can be moved. Consider from robotics to aerospace to drones to whichever. And so, yeah, we estimate that these roles will be in the millionth range, and we are trying to define them. So to define them, we look at some market reports, and we thought, well, there's still going to be pilots. Obviously, we have people like Gabe on our board, and clearly, there's some talent that cannot be replaced. But there's a lot of new aircraft appearing, so we expect they will be teleoperated from the ground, flying cars, new drones, new planes. There's going to be more AI to control everything now that things will not be driven manually. So all of that needs to be handled, and then there will be a huge amount of data. We'll be doing more digital twins, more simulations, and more of that. And hopefully, all that simulation work goes into defense as well, and it will give us a better idea of how to control things in a diplomatic manner before they get out of hand. So the curriculum, the general idea is we work with companies to define the curriculum. And this is the new approach that we're bringing into the Neurotech program. Again, if a company says, you know what, in the future, we aim to hire, 50,000 people on airspace control with machine learning, because our airports are going to have all sorts of things, drones, planes, flying cars, vertiports, then we will start training on that, and we will build a curriculum with those recruiters to help understand how that's going to look like across the board. So the curriculum is ever changing, and one of the nice things about being a private learning institution is that we don't need to wait, for administrative processes. We can switch this within weeks if we need to. So this is good for the companies because they get to recruit people that are trained exactly on what they need, and that's not something they can get in a 30-minute interview. And it's obviously good for the people in the program because they get trained on skills that the industry actually needs. So a few of the people on the board, Damon is not with us today, but he's helping us on aerospace, Gabe on defense, Maria on mobility, and Fred is doing the spatial computing part, and I would say, well, now definitely the neurotech part. More professors and mentors. So there's a total network of 50,000 industry leads, which will be interesting for neuroscience. In the neurotech field, we will be bringing in a lot of academics, also Professor Histopoulos from Caltech. So we will be working with different institutions, different research centers, different hospitals, and the emerging companies out of this. But there's also older companies. For example, if we take AstraZeneca or all the biotech companies, companies like Medtronic, Neuropace, all of these will be helping us jointly to define, where this is going. So same model as for everything else. We're growing our team in Barcelona and our community here, and we're expanding in Europe and in the US. There's two sides. One is more academic for the neurotech side, and one is more executive for people that are actually excited about neuroscience and want to learn more. Let's say they study biotech, they worked in biotech, they want to switch to neurotechnology or whatever. Let's say they study machine learning or something else. We have this graduation bit in Schönbrunn Palace in Vienna, which is the second largest palace in Europe. It's pretty cool. And because all of these programs are accredited globally, you can also have it notarized, you can have it recognized at least in every EU country, but also now in the US, and we're looking at Asia. And so getting to the Master in Neurotechnology, then I'm going to take a break, Fred. So the idea is that we still learn all the neuroscience and the neurobiology that's really needed, but we also get an overview of the industry, because it's very rare that neuroscientists get both. And there's also going to be a lot of training with expected deliverables within a short amount of time. We will have a demo day where future neurotechnology graduates will be presenting their company idea or their project idea, and it needs to be investable, and it needs to be something that, say, AstraZeneca would want to invest in, right? So it needs to make a lot of sense from the financial side, from the technological side, from the scientific side. Your presentation skills need to be very good. But there are also other elements. There's, of course, the master thesis, which is 100 hours. And as you form your overview through the career development template that we use, you are going to be, let's say, in the 6th month of the program. And this is when, if you send your deliverables on time, some of the mentors are going to be interested in mentoring you and helping you out. So by the end of the program, you're going to have a very strong network backing you. This is very rare. This is almost never achievable within a master's program, but that's kind of what we're trying to do here. And so I mentioned that, after demo day, things don't end there. This is not that type of program. You have dedicated career placement support with a lot of warm introductions, but the idea is, one thing I've learned, probably Fred can confirm, it really, really matters who you know in the industry. It's a very big difference. Already, some of you know, those who are in neuroscience, that it really matters, who your supervisor knows, if they can recommend you. It's a very similar process in industry. It's not just applying on LinkedIn. Your network is your net worth, and it's really important. It's as important as your neuroscience knowledge. So now I'm going to give you a program structure of what is expected to be delivered. This is an actual screenshot from the program. So the whole thing is 1 year online, and you kind of go through it step by step, and it will open new chapters as you go through them. So just a general overview, but there will be a pitch deck that you need to present. There will be the career progression template, the business plan, which is going to be 30 pages. You're going to create a financial model, an advanced financial simulation, and ultimately the 100-hour thesis. And so for the masters, I mentioned that we will go deep into neurobiology and neurophysiology, and this will come with exams. This is important because then when you pitch to investors about your neuroscience, related company, you will become a lot more credible. And regardless of whether you decide to be a technical person or more business oriented or sales oriented, this first part is really important to know, as is the second part with data analysis in Python in neuroscience, but we'll also learn, Unity and a bunch of other things. Ideally, you specialize in something by then. Neurotechnology and brain machine interfaces, just to get an overview of what's out there, what are the different technologies and what's the difference between them. We're going to go a bit into what I studied and what Freda studied, which is biomedical imaging and optical techniques. We had to learn a lot of optics to put those microscopes together, and you will too. It will give you a lot of clarity into how we acquire the data and why is it in the way that it is. We're going to go into neuromorphic systems and neuroinspired AI. So that means algorithms that are neural networks that have some kind of level of inspiration from the brain, whether it's spiking neural networks or something else, or sensors that are inspired by the brain. You're going to learn about those and why they are like the brain. And then biometric technology. So this is something we used in robotics. So for example, eye tracking and the VR goggles, these haptic gloves or haptic suits. These are ways to acquire biodata from people. Then neurotech innovations and entrepreneurship, learn about the landscape, but also learn about what can be done in academia. Why do you want to be an entrepreneur? Why do you want to be in neurotech? And you will have to be very sure why you're going into corporate at the end, or why you want to start your own company, or why you want to stay in academia. That kind of clarity would also help you be happy with yourself and not just going to the next position because you're pressured. And then just kind of going into the financial modeling, the business communication side. So that's kind of the overview, and I'm just going to stop there. Fred, if you have any comments at this stage about the program, like what are your thoughts also on neurotech as a whole?
Yeah, I think the big thing you're pointing out is the true multidisciplinary opportunity in the curriculum. And then when we look to the community, you kind of see two people, right? You see people who are deeply steeped in the techniques, the foundational knowledge of neuroscience, who've spent many years exploring these dynamics and other issues, computational thoughts around how the brain works, how the nervous system works, and opportunities to interface with the nervous system and potentially actuate the nervous system, for benefits to neurological disorder or even from human performance perspectives. But you also see the other side of the coin where people approach neurotechnology more from the business side of things, and so there is a lack of kind of being in the middle, right? And so there are many who've done a great job at translating across those domains and building some interesting companies, but there aren't that many people, and so instead of taking it to chance that we develop the next generation of entrepreneurs, generation of thought leaders in the space, this is taking an intentional opportunity to provide the relevant skills, relevant experiences, and relevant knowledge base to begin the process of developing into that next generation of innovators in the space. Because one of the real big, really big, sort of a pitfall, but I think a tremendous opportunity, it's to really understand why neuroscience is hard, and why it's difficult to build neurotechnological solutions, and to, as we think toward how we describe this to, venture capitalists, to, just the society, we need to understand where the pitfalls are, where the challenges are that prevent the eventual application of these approaches to the markets, and the fact that there are new markets emerging, and truly understanding the dynamics around what those markets could look like, and even today where those markets don't exist, where we can build new opportunities to actually fill market solutions. So there is a tremendous possibility and opportunity from this type of approach. We think this is a unique space to work in, and it's exciting as we explore these the future of the fields and the merging of fields, really, where we have many discussions within the academy, amongst our board members and professors around these issues that we think it would it would be a great possibly a great opportunity to be involved in this movement.
Definitely. Yeah, and I've been meaning to ask you, Fred. So actually I studied philosophy before, so my major was philosophy before going into neuroscience, and like one of the reasons I decided to study it was because there was this philosopher I really liked. Her name is Patricia Churchland, and she and Paul Churchland were talking about how we cannot really talk about reason or the limits of our mind without talking about the brain, just because science has done, so much amazing progress in that sense. And then I was like, that's it. I'm not reading pop science anymore. I'm gonna go and do a PhD and like do the hard stuff. Um, I am curious in that sense, like what brought you into it? Because sometimes when you are trained in biology, you go into biotech or neurotech, or for whatever reason you get into this field, you kind of just go in as, or if you have like a medical training, you kind of just go at it and you're like, okay, I'm studying this protein. Why am I studying it? No idea. Or or why am I working on Alzheimer's? Or like, and I think what I want people to invite to think about in this program is why they're doing this. Like, what is the purpose? What problem are they addressing? Like how does that make the world better? Because certainly a lot of them are going to be very intelligent, very capable people. So it really matters where they put their energy. So like starting with that question, why? And I know why more or less I got into this. How I got here is another story, but I'd love to know your why, Fred. Like, what brought you into neuroscience, and then into DARPA, and then into all of this.
Yeah, so I started really from a fundamental question, as a biology major in undergrad, just learning about sensory processing and really just having a hard time believing, just how sensory transduction works. I was like, is it really that simple of a process? So began this exploration, in vestibular physiology, and directing the approaches to the actual sensor, to the hair cell, and understanding that transduction process, and then that in doing that, realizing the complexity of the system, and the fact of moving to the Army, working with DARPA, where now we need to think about much bigger issues, real world applications, um, not necessarily in the near term, but with the far future focus. How do we actually go from foundational knowledge to real world application, and exploring the applications of interest in national security and defense, relevant to neuroscience? I began to think back to these molecular processes, at single cells. I study at the single cell level. Friends at the tissue level, the behavioral level, social levels, and being intrigued by the fact that one of the biggest barriers in neuroscience is that we don't have multi-scale description, of any process, which makes it very difficult when we begin to think about it from the perspective as a neurobiologist trained to focus on molecular mechanism of disease, where you know going after molecules always doesn't work. Biotechnology, biopharma hasn't been extremely successful in hypothesis driven approaches, who's thinking that, hey, this molecule, if we fix it, if we fix the output of this enzyme or protein, that'll solve this disease. That rarely works out because we don't understand how that fundamental process links across cellular domains, across tissues, that then lead to behavior and social dynamics. That doesn't really exist. And so from to going back to your philosophical background, that's where I end up sort of later on in my career to realize that there's a pretty big challenge in science in general, but particularly as we approach neuroscience and building neurotechnological solutions, as we started off a little over 10 years ago trying to do. So that's sort of my why, is to really be able to de-risk and enable thinking around like these philosophical challenges to help us, to help us navigate, the road to building new technologies, new products, new solutions to solve these basic challenges in that affect neuroscience. Because there's significant social implications, ethical implications, legal implications, all sorts of issues around this that if we don't, we need to do this right. And we one of the things I really loved, just kind of sitting in the background as DARPA executed a brain initiative, was exploring, with ethical, legal, social implication panels, for all of the efforts, really thinking about these issues before they, before we build products, before we get deep into the science, to really think, what does this all mean? And that's, I now see that as one of the most exciting opportunities at this intersection between neuroscience, technology, market solutions, social implications, all of the mix, and to consider them all in one space, as we hope to do within the neurotechnology master, is a unique conversation, a unique training experience, a unique multidisciplinary network that leads us from foundational knowledge to operationalizing and making actionable outcomes that create real world solutions.
Amazing. Yeah. I think I understand your why now, and it shows. I mean, you kind of started answering it, and I mean, based on our discussions with the board, it all connects to this, first principles thinking that we were discussing, right? To really start with the question, why is this relevant? So I think in your case, working with DARPA, working with the Army, then you can really start with some fundamental questions, and then you can ask, how do we go about it? This is a question that maybe neuroscience should answer. How do we go about this? And as you said, it's probably going to go through many levels. The question will not be answered just at the molecular level, right? Because there's a causal connection between the molecular, the cellular, the network, the behavioral, all of these, right? And then the ethics part is really important. I'm so glad you started discussing this 10 years ago, because it's only the last few weeks that UNESCO published their neurotechnology ethics analysis, right? And this is exactly the kind of thing that we want to be careful with in advance, preemptively, before. If you read Neuromancer or any of these like sci-fi books, there's a lot of issues with cybersecurity, with data, when it comes to neurotech, all of these things, right? And about this, like I've been thinking, at the end of the day, I think many of us, we have our path. We try to do things slightly differently than the previous generation, but at the end of the day, we just want like to help some people in the new generation, have the, let's say, like a faster pace than we did, but also to make more of us. I'm sorry, it sounds really bad, but just to allow more people to kind of follow our footsteps, and then ultimately decide what they want to do. But I can say, as an example, I always like to tell people in our community, look, this is what I did. You decide what you want to do. But I'm just giving an example because I think it adds value. So the fact that in our case, I tried to connect spatial computing with VR, because I figured if we understand how the brain maps space, then we can build algorithms that map space better and more efficiently. And then we can simulate those, like Google DeepMind had this attempt, and it found that the neural network developed these brain-like grid maps, just by being exposed to an environment. And there's this theory that, since our brains have been evolving for millions of years, why reinvent the wheel when it comes to algorithms, right? And I feel like this goes into the whole LLM discussion. It's very possible that some insights from the brain about the structure of how we form perspectives on the world might actually be helpful, because LLMs at the moment are very black boxy. Our brain is a bit less, so we try to bridge the gap. But I've seen students who, for example, had a very consumer focus when it came to neuroscience. They figured, let's take the facial expressions of people that look at products, right? Or even political ads, and let's see what we do with that data. And that opens a lot of other things. But, like there was this movie Minority Report. I don't know if you know it, from the 90s. And there was this scene, right, where he's walking through the shopping mall, and then someone from the Gap approaches him and says, "Hey, we hope you liked the last T-shirt you bought. Would you like to try this one?" Right. So they had like all of his search data as well as like facial recognition and all that. And it's crazy that now we're so close to that. And then some other people will look at brain machine interfaces in a very different way. I mean, I look at Neuralink. I'm not sure what to guess. I mean, they seem to have a motor cortex focus, and brain machine interfaces have had this neuroprosthetics focus, like prosthetic arms, prosthetic limbs. For, I mean, you work with DARPA. You probably know better than anyone just how much work has already been done on prosthetics, right, and on sensory prosthetics. So what does that mean? So I gave a few examples of things that can be done in neuroscience. Do you have any others that you feel generally excited about and don't even have a clear plan where you're like, oh, we need to study this molecule or we need to study this, but it definitely seems like something that people want to know about?
Yeah, I mean, there are quite a few exciting spaces, but one of the, I think at the forefront for me personally, it's one of the pushes we made before I left the army. It was one of the fundamental questions that I was grappling with for many years was thinking in this space around, particularly from an AI perspective, a neural AI point of view, that just this idea of artificial neural networks, right? And that it's supposed to be brain-like. That's not the way the brain works. The digital code in the brain, it's exciting because we can record it, we can see it pretty easily, and there's good mathematical description. Thinking about the single the point process function to abstract that phenomena into what has now become artificial, as advanced artificial neural networks. But to think broader about, does the brain really work that way? With the challenges we see in energy efficiency, many of the other you know, processes involved in just those algorithms, there are opportunities from brain neuroscience that actually solve those problems. To even think about just the fundamental computation in the brain and the idea of it's just spiking in the brain, where actually most of the communication probably occurs when you're not spiking, when you are quote unquote resting. And there's quite a lot of sub-threshold information that we miss that we don't have strong technological solutions, particularly at that nano domain, micro domain to explore, where the brain has solved these basic challenges. So while we think toward technology of today to realize that there's so much untapped potential from neuroscience, and just understanding the brain at multiple levels, where we can be thinking and moving toward abstracting processes for building future systems. So the use of or the conversation and how we use AI at the moment mainly focused toward AI as a tool. You know, kind of then on the flip side, seeing more neuroscience as a tool. And so really moving toward new foundational approaches to bio-inspired AI that build in these unexplored or underexplored spaces of neuroscience that aren't quite as sexy now, but that I anticipate really hold the key to future advances that will tremendously advance the possibilities for AI. So I think that's really the place that excites me the most right now.
That's really cool, actually, this approach, and it kind of brings me to the neuromorphic systems and neuro-inspired AI bit, right? When we started with neurobotics, our promise to investors was that, in principle, the energy consumption reductions can be 10,000 fold. So now, with tools like ChatGPT and others, they really raised interest, like lay people's interest into working with AI, right? And a while ago, probably 10 years ago, Elon Musk was talking about this bottleneck between us and AI systems long before ChatGPT started, right? He was saying that if we could find a really effective way to communicate very quickly and with very low energy consumption, it would eliminate this bottleneck, right? Because now the bottleneck is our phone, or maybe for some it's glasses, right? But imagine, having no limit on either side, having like a fully neuromorphic system, being able to record things directly from the brain and having a neuromorphic system that encodes, maybe with a spiking neural network or some kind of neuromorphic architecture into a neuromorphic hardware, right? The entire thing would probably function similarly to the brain, and that it would compute such complex data at such a high speed and probably use less than a light bulb. Like this is the promise in a way. And to me, the finality of neurotech is full stack neurotech, right? That would be truly full stack. And like I said, with LLMs, there's this question now: is it a bubble? It's definitely black boxy. We have little control over what happens in between the input and the output with LLMs. And so this might be a good time to, to bring back architectures that maybe are brain inspired, because for us they will be something that we're familiar with. But yeah, I mean, and the best part about this discussion, Fred, I think, is that, you and I have been back and forth between neuroscience and different industries, and this is what we come up with. But what really excites me is what people come up with that has never crossed our minds, right? So we had quite a few like applicants also that had very interesting ideas. Also in the medical field, the medtech field, the biomedical, we haven't even touched on the medical side yet, and what could be done. So yeah, very, very exciting stuff. I'm curious, like from your time at DARPA, if you feel like there's something in particular that we should cover. One thing that we want to push when we onboard students, we have now the possibility of partnering with different institutions. And obviously, we want to take students and partner with only initially the Ivy League neuroscience, institutions, the top ones. And yeah, I'd like to see, in which direction we can take that. What is it in DARPA that perhaps, has huge potential or has been overlooked, or maybe took too long to develop, or maybe was not interesting enough to investors to immediately invest in, or wasn't blue sky enough, but maybe where you saw some potential, if at all. I mean, if the answer is you didn't see anything, is fine, but.
Yeah, I won't speak too much for DARPA now, as former government employee. But I think there are really interesting spaces to explore where there are some pretty interesting commercial successes at the moment. Because we've been kind of speaking at the level of higher order nervous systems, or even human brains. But I think even exploring possibilities in really lower vertebrates, invertebrate nervous systems that are simpler and that are easier to replicate and even easier in many ways to interact with. Um, there are I think pretty interesting ways to like focus some of the applications we're talking about toward like nearer term solutions that can have easier demonstrations, easier MVP um, outcomes, and easier exploration of you know market interest. Um, I think that's sort of the place where I tend to kind of like, after thinking about the long period of advances, that's sort of a missing piece for us. We've had pretty complex roads to realizing the outcomes. I think part of it's because we're looking at pretty, particularly in the med tech, kind of biomedical space, neurological disorder. It's pretty tough it's a tough road, and a road where, from an investment point of view, not always attractive, right? And so difficult in many ways to convince that, this is the solution. We are the team to deliver, because there's so many unanswered questions. And so the ideas around risk in the space have, they overshadow quite a lot of the opportunities sometimes. And so I think the space where, we're kind of seen where we need to make more immediate advances is sort of an opportunity for quicker wins. And so leveraging spaces where there can be quicker wins to, you know, to demonstrate like there really is a future for the space, the sector is a great need, and one where, I think the most emphasis can be placed right now.
I'm so glad that I was sure you're gonna have an answer for like potentially overlooked technologies, and I overlooked it as well. So drones and neuromorphic drones, brain inspired flight, also biomimetics. Like I've seen some great labs in Zurich, but I'm sure there are many in the US as well. For example, that imitate the flight of insects, or their cameras, the event-based cameras. There are a few labs that are quite famous on this, and I think perhaps with the current state of affairs, with the current Eastern threat, there has been a growing interest in drones, and potentially, actually defense might create a wave of interest in drones again. They had a hype a few years ago, and then it went down, and now it's going back up with the defense applications. But yeah, I think definitely very, very interesting biomimetics in general. I've seen a robot lizard, where they sort of imitated the spine move of the lizard, and it was actually designed to save people from burning buildings, or buildings where, let's say, it would be dangerous to send humans inside. That lizard could like crawl under a door and then kind of bring people out. So these kind of applications that, again, where sometimes you see the results and you realize you did not see this, you didn't see that possibility. Which brings me to the point of, you have programs like DARPA. Now we have some programs in Europe, and they will still appear. We probably don't know. I'm sure Asia is very, very advanced as well. So what I would like to do with this program is to kind of create some bridges, right? If we already have most neurotech companies involved, and some investors that we already know. We have a few institutions involved. And I think what we will be able to do is to start mapping a space between the ideas at different levels and how they enter true product market fit in the industry, right? And we can see some examples already with the drones or whatever. And in time, I think with data, with more and more students passing through this, we will be able to map that space better and better of, neuroscience going into high TRL neurotechnology, right? With wide applicability and wider funding. Is that something that, if I may ask you, have looked at yourself? I will not say through DARPA or any other mechanism. I wonder if the European funding system should look at it. I work as an evaluator for one of the main European funds for tech. So I wonder if we should, if it would help, do you think, in neurotechnology to map the opportunity space? Let's call it that way.
That's an interesting idea. Yeah, there have been, people have mapped the space quite nicely, I think. We've seen several reports come out around this. So I don't know if there necessarily needs to be a recreating of the wheel there. I think there is within mapping, there is the potential to be a little siloed and thinking that this is the entirety of a space, when neurotechnology is such an emerging technology space that there's a possibility for so many more potential applications that we haven't even thought about. So I think there's tremendous potential within the next 5 years for quite a bit of first mover opportunities and building new markets where we can be focused. And so I think that's the biggest part about thinking of the neurotechnology market, beyond just the snapshot of today. It's to, because in some places you may think that, it's a bit sad, from a perspective of a student, a postdoc, and even junior faculty, and just thinking about the STEM training pipeline, or even undergrads, having mentored quite a few over the years and have ongoing discussions around some of these perceived challenges of like, how do I even break into this? Because it's such a fast moving space, and because now there's so much more investor interest in driving these technologies forward, there's a bit of a gap in the marketing around where the opportunity lies and the realities of, you know, this is such a huge space and there's so much potential to build and to grow and to move into spaces where that were unimaginable, just a year ago. So from a depends on if you're talking about it from the entrepreneur investor perspective versus thinking about it from the trainee perspective, where I would say it's an exciting, extremely exciting time to move into neurotechnology. To whether one directly approaches it or not, just to understand this translation from, as we kind of pointed out, from foundational science through to the development of knowledge, the intersection with the dogma and the foundation of a field, that's been growing over the past 70 years, 70 plus years, or really even longer than that. But the growth of this field into this emerging technology space that's now going to be now enabled by new emerging technology, the fourth industrial revolution, through cyber physical systems, that the uptick is going to be so much faster, and the potential to integrate and to expand the field, um, it's ripe, and one where trainees need to, I think we need to be exploring.
1000%. One more thing I noticed is, I mean, you know that from most sciences, probably neuroscience is the one that operates in silos the most. I remember going to conferences and the cellular neurobiology people wouldn't even talk to the computational ones, let alone the molecular. Like they will not even talk to each other in the lunch break. There is like a historical anger there. And one thing that we noticed with companies that had to scale, and that's something that we know from the startup world, is actually you need all these people to be working together. Initially at Neuralink, people weren't even required to know neuroscience because the focus was so much on the robotic surgery device that at that point they just needed a lot of hardware engineers and software engineers, right? The surgery and the conceptual understanding of neuroscience comes much, much later when the thing works. And that I think is actually a very healthy approach. So one thing I would like with this master in neurotechnology is I've already seen, like, we had quite a few applications from different fields. There were people that wouldn't like dare to, go into full neurophysiology, medical doctor work, but were fascinated by the field. And I'm happy with that because what we can do in this program is really differentiate between them. Who are the people who want to do the masters and end up being in VC and focusing on neuroscience? Who wants to work for a government and have the neuroscientific edge? Who is a great storyteller and wants to talk about neuroscience without having the deep medical understanding? They will have to pass basic neurobiology, but not, advanced experimental work, for example. And then all this stuff. Of course, there will be neurobiologists, there will be, philosophers of mind, there will be like cognitive scientists, there will be people much more on the computational side. And what I want this program is to kind of gather their performance on each of these things and just to give the wide overview. And a lot of people will realize, what, maybe your thing is you're a great storyteller, like you're an extraordinary storyteller, and perhaps you can explain neuroscience in a way that no one has before. Maybe you read sci-fi and stuff. Or maybe another person is a fantastic experimentalist. So I think one thing that happens in academia is you get so pigeonholed, right, in a box sometimes, that there's also this fear, of course, and I want people to not act out of fear in neuroscience. I think it's a great place to be playful and to be excited about the future. And I think if we end up doing neurotechnology with an excitement about the future, then it will affect every industry in ways that, like I said, we cannot imagine. It's the only industry that when I think about it, I actually cannot fully conceive how it will look like in the future.
I mean, that's the biggest question. Where are we headed? And particularly at a time of global instability. I mean, it's and sitting in the spot of a trainee, is almost unimaginable today. Thinking about what does the future hold for me? Someone who's really trying to explore where they're going, where they're going to, be placed in new markets, where they can find a place that's safe, We are at a time of talk. There's a lot of talk around. Hey, it's okay to get rid of employees. We introduce AI into the mix. So there's quite a lot of conversation that a lot of it's not particular. I don't particularly think it's like it's as dire as it sounds. I think it's actually really exciting, but it's where one of the issues with the training pipeline is that being in an academic system, it's not historically been focused toward the transition of trainees to the work outside world
Yeah.
and the world, particularly a world outside of academia, sort of puts you into this mental space where I talk to a lot of my mentees about, that it's like it is an internal issue that we have within particularly those in the kind of doctoral part of the training pipeline, or those thinking about the doctoral training. We see that training as one thing and leading in this one space, and which ultimately leads to a lot of frustration. Where now you have you know, most of your people in doctoral pipelines globally are not going into academic careers. And that even dating back to the 1945 documents in the U.S. Folk thinking about like where does defense fit within federal funding space, in basic research. It wasn't just for the sake of research; it was for the sake of bridging foundational knowledge to applications and industry, to industries and relevant sectors of national interest, broadly, whether it's the national economy, national health, the national goods are where we're connecting. That's thinking about it globally. We need multidisciplinary understanding. These the trainer common training, but from many different perspectives that can advance advance our solutions across sectors and create new sectors.
Yeah. Yeah, yeah, and this is really it. I mean, I think you hit the needle on the head. Is probably why we even made the program. Is because when you're in academia, you get stuck in this race of publish or perish, and it's also now quite similar in startups, right? And it's hard to take a step back and think, why am I doing this? Why am I working on Alzheimer's? Does that interest me? Is it important to me? Is it worth the next 50 years of my life? And that's why I also said like we should try to see this from a joyful, playful perspective. This should come from an excitement about, the curiosity of knowing more about the brain. As we are curious about understanding space, and seeing a supernova should give you a similar feeling to seeing the inner workings of a neuron that no one has seen before. It's exciting. It's really really cool, right? Um, and with the whole publish or perish thing in academia, and with the gig economy appearing in industry, this is also a time to think differently about what we said, like what you said very nicely, that there is no future in which human beings do not have careers, especially the most talented people. They should have careers because it pushes humanity forward. If they get stuck in a gig economy, they cannot fully express their ideas.
Right.
And again, like the thing with big visions, right? If different types of people go through this neurotechnology masters, one of them is a CEO type, another one is a CTO type, another one is a programmer, another one is an experimentalist, another one is a great marketer. And all of these people need to work together if they're going to realize one big vision, just because also the structure of academic grants is such that you have, a lab, you have a few postdocs, you have a few PhD students, you have a few master students, and they just kind of have to publish. That's the structure in which you're and it hasn't changed, right, for decades. But what if there can be a different structure? One that also allows people to not worry about what country they're going to be in, especially if they want to start a family. Like there are all these things that are so relevant for at times. But yeah, in short, we're trying to do things differently, and let's see how that goes. What I can say is I meet people like you, and I have like a genuine excitement about where this is going. It could go badly, of course, but perhaps, if you train a bunch of people in the right way so that they have the same intrinsic motivation, maybe they come up with ways in which this goes so well that we probably couldn't even have imagined it.
And therein lies the need for people from all different perspectives understanding neuroscience, understanding its limitations, understanding its the gaps in knowledge, and understanding the possibilities for the future, and how those possibilities fit in with society, with you know people broadly, with workers, with scientists. We need to explore across the entire spectrum of experiences, because the brain is it's ubiquitous. It's in every conversation and every application we speak to at the end, particularly where humans are involved, a brain will be involved. And so whether it's at the psychological level, whether it's really at that we're talking at the single neuron level, or even like at the human machine interface level, human autonomy interface. Those are extremely, there's an extremely vast space of possibility that in some cases makes it daunting to explore where to fit in this space. But it's one that's excited so many of us to explore, to enable, and to make it possible to be here today. To make these hopefully revolutionary leaps in the near future in our understanding and potential application.
Yeah, indeed. Well, this is everything I was hoping for this discussion. And surely, we will follow up with other things. You'll see on the website there are some micro credentials, which are 4 months and they're shorter. There's one on biotech if you don't have time for this. And, here you can learn how the program works. Here are the tuition fees. We do work with scholarships with a lot of universities, a lot of funding bodies. We work with corporations that might want to sponsor some of these programs and some of these students, as well as potential investors. And yeah, ending with this kind of excitement, I love getting crazy ideas and people who are applying and seeing their videos and what makes them excited about this. With this in mind, we're obviously looking for talented students. We're focusing mostly on neurobiology graduates, but we are opening now. I'm actually quite happy to see engineers and people coming from very different industries going into this, see how it goes. And we're also looking for professors and people to be working with us that might have noticed in their lab they have talent and maybe it doesn't fit the standard PhD, postdoc, master student, publication, PI structure. And and potential investors that want to work with us and who want to make sure that they don't invest in pseudoscience ever again. So on that note, it was a pleasure, Dr. Gregory. Thank you so much for your perspective.
Yeah, thank you, and looking forward to new students in the curriculum. Let's
Indeed.
build the future.
Yeah, let's do that. Let's do that. And yeah, thank you so much for your time. It's amazing to have you on the program. And we will try to see which students would like to get in touch with you when they're ready for mentorship, and then continue expanding the network from there. But yeah, thank you so much for your time, and thanks everyone.